All right, so I'm going to be starting out on how to do CAM in Fusion 360. There is a slide portion to this training as well that kind of covers a little bit of the overview of how to do CAM, but this is just going to be a recording on the actual doing the CAM in Fusion 360 itself. If you are opening a part, you probably will have a window open on the side. You may or may not be in the design workspace up here, which is where you can make sketches and other things. We will sometimes be going back and forth between the design workspace and the modeling workspace if you have something that you need to remodel, need to update, or if you say bring in a step file, it may not have some of the information about what you are trying to machine. Primarily, all of this is going to take place in the manufacturing workspace. So I've already done this a couple of times, but I will set it up from the beginning again. I'm actually going to turn off these sketches just so we start to see just this sort of demo part. Part of what I'll go over in the slides is assessing our part to see how we're going to machine it. And we've decided that we're going to machine it from two sides. This side being our pocket side and this side being our shaft side. There is this third hole that would either take a third operation, or we could do it as a post-processing operation. We can do it just on a manual mill. We might decide later that we just want to do it on the CNC mill or do it with hand drill or something. So we're just going to focus on those two sides because those have the critical features. We've also decided that because there are flats on these two sides, those are going to be ideal for holding in a vise. And that makes it possible for us to start with this side machining first, and then we're going to flip it over and machine it from this side. We'll also have the opportunity to use this middle bore, this shaft that's going to be drilled first and reamed from this side, and that'll be available on the other side. When we flip it over, we need something to indicate to figure out where is this part inside of what is going to be a block of aluminum. The first thing that we need to do for this is we've decided that we're going to machine it from this side. If you're opening the part, you might actually also notice, I'm actually going to go change this really quick. I think that, all right. All right, so the first thing that we need to do is start a new setup up here. And it's going to ask for a couple of things. The first thing that I want to change is the orientation. So this is actually the correct orientation that I want to machine it in. Oh, actually, no, we're going to start from this side. So this is not correct orientation. I'm going to use Z-axis, Z-plane, and X-axis. So I'm going to select my Z-plane. And then this X-axis is fine. But if I wanted to flip it, I could flip the X-axis or make it orthogonal to this. I'm going to skip actually origin for now. I'm going to go to stock. So this is where I'm going to define the piece of material that I'm going to be cutting this out of. There are a couple ways to do this. I might use relative sized box, which will add an even amount on all sides. Frequently, if I'm starting with a piece of material, I'm going to start with fixed size box. As you can see, this height that it'll sort of find whatever the closest inch number is. This height is actually exactly the same as my part. So I may need to either adjust my part size. If I machine this as defined, I may end up with a little bit of uneven surface on the top and bottom just because my starting stock is exactly 1 inch also, and that'll have a little bit of an uneven surface when it comes out of the factory. So I may want to either add additional height. I want to probably add a little bit of additional X distance so that when usually I'm probably going to cut this out of a like a 1.25 by 1.25 by 1 inch block. So, or maybe I can find a 1 1/8 inch block or something so that I have less material on both sides to cut off. So you may need to go look and figure out what is available. I want to maybe give myself a little bit of extra space on both the sides that are going to be saw cut because they may be uneven. So after I've defined that, I want to go back to my setup. Now I'm going to define my stock box point. This is going to be sort of the origin and where I'm going to, when I put it in the machine, I'm going to say this is sort of the zero, the starting point from which I make all of the CAM toolpaths. It is important that that is something that I can actually find on the machine. So if I wanted to put it on one of these features, those features don't exist yet. It is this yellow block. I just have this sort of nondescript piece of material. So I have to use something on this piece of material that I can reference. And often in manual milling manual and CNC milling, that frequently will be the back left, either the bottom or the top corner, primarily because it's usually in a vise. And a vise is going to have a fixed jaw at the back corner that is more reliable to reference. So I've figured out where my socket's going to be at the top of my model. It's going to be at this back left corner. And now I'm ready with my setup. Now I might also want to, you can right click and edit, call this something like, slide A or slide pocket side. I could also name this by clicking this. I could say pocket side. One in here in the post process will just name my file this. So it can sometimes just be convenient if you're posting the file several times, which often happens. So the next thing is I'm going to think about what do I need to do from this side. I've maybe assessed already what kinds of operations I think I need to do. I have these drilled and tapped holes, which we're going to skip the tapping just for this training. We have this main drilled hole, and because it's for a shaft, I'm actually going to use a reamer instead of a drill or an end mill to cut this, so it's more accurate. And then I have the rest of this part that needs sort of this pocket cut out of it and the outside cut out. So that then when I flip this over, I can just cut basically this and any of these like little chamfer pieces, and then my part will be done. So a lot of times I will first start with like a facing operation to kind of get it down. Then I'll do my drills. I'll do any interior features, and then I'll do all my exterior features just in case something goes wrong. Usually that happens in that exterior feature. So if you loaded the if you loaded the Fusion file, it will already have a tool library included. If you did not use a step file or something, you may need to download the tools file separately. So you can go into like Cloud, you might have these loaded. Tormach 770M, that's what we're going to be using. So this will have a list of many of the tools that we have. This is sort of like my standard tool list that I have in the Tormach. Many of these already have some cutting data that I've tried out. I won't say that all of these have accurate cutting data. I have updated all of these, so we don't have to go into that too much. That feed and speed work is often a lot more related to, using sort of lookup tables or trial and error or asking me. I also have a number of these like drills of different sizes. Often I will have people use the end mills that we have that are like predefined, and then the drill you're going to have to adjust a little bit to whatever drilled hole, but you can start with something that's a little close to the right size and then adjust it as needed. So next, we're going to actually start with our toolpaths. We can also define our tools as we go. I frequently have a machine tool library already, and then I might define one or two tools as I go. My first thing is going to be in the 2D section. This is really going to define like most of the toolpaths we're going to find here. There are drilling toolpaths. We're not doing anything multi-axis. 3D toolpaths we're not going to be using for this specific purpose. These are mostly all just ways to do the same thing, which is how to make organic surfaces, essentially. So 2D is where many of our processes are going to be found. So I'm going to select this for facing, and I'm going to select the face mill. I can use sometimes these filters if I have a lot of tools, but I can go down here in this Tormach fly cutter. So if you see fly cutter or face mill, it's good for facing. You can use an end mill also, but this is going to be the right one. I'm going to skip multi-axis tab. We're not doing any multi-axis. I'm going to go to geometry tab. Now, whenever I do the face mill operation, it is automatically going to select my stock. So it's going to select whatever the stock is that I set up. And I don't need to do anything else. Heights here, it's going to show the top height, and then anything, if you're wondering what these mean, you can always hover over it, and it should open up a window and kind of explain what those different parameters mean. I am looking, though, to cut away all that stock. So the start of the cut area is going to be that stock top, and the bottom of that cut area is going to be the model top, the surface of this model. I really like these sort of parametric ones as opposed to, I have the option of selecting it directly or defining it in some other way. Let me go back actually to model top. That works well, but sometimes if you adjust your parameters or you adjust your model, it might break. Having these sort of referenced features is helpful. In passes or face, this is where I get to define how it's going to be sort of cutting, how many passes does it go across, how many passes does it go down. So for this, that fly cutter is 2.5 inches in diameter, so it only needs one pass, but I may want to define multiple depths. Typically with fly cutters, you don't really want to do more than like a 1/16th, I'd say, depth. So I'm just gonna say maximum step down. I'm gonna put it at that 40 thousandths, leaves that there. I probably don't need to do anything in linking, but I'm just gonna leave it as whatever the default is. And then that's showing me my part. Now, if I had done no depth cuts, it would have just done one big pass. It might have been fine. I think that there's a little bit too much material, and usually you'll get a better surface finish if you do multiple passes and nothing too deep, because it's a little aggressive. If I also wanted to change the direction of this, I could go back into the passes tab and change the pass direction or pass angle. All right, next I want to do drilling. So first I'm actually going to do spot drilling. It is better than going straight in with the drill bit. So I'm going to go and select my 1/4 inch spot drill, number 28. I may need to check if this is aluminum. That will be something that's I've already checked on the Tormach. We're going to go to geometry. Now we're going to select hole faces. We could select all 4 of these. There's also the option with holes is that you can select all of the same face diameters. I can also select this one. If there was more than one hole, it would select these other ones. I'm then going to go to heights. Now, this is going to basically define where does it start drilling and when does it end drilling. Now, this is supposed to be a spot drill. Oh, it did not grab my hole face. There. All right. Where does it start drilling and where does it stop drilling? The default for holes tends to be it starts at the top and it ends at the bottom. You can see if you look over here, there's a little bit of preview. It's not going all the way through that hole. This is also a spot drill. I don't want it to go this deep. I want it to go just tapping at the top. So I'm going to change my bottom height I'm actually going to change my bottom height because this one, it's starting at the whole top. It is going to, there's material here still. If I cut out this pocket, then I could leave it. I'm going to actually start this at model top. And I'm going to also make the bottom model top, but I'm going to give it a little bit of an offset. So this will be a negative offset, say, 30 thousandths of an inch. And now it just is kind of tapping that hole right at the middle, and that'll help guide my drills in the future. I'm not going to do anything about cycle for this spot drill that I do with deeper drills. And I may want to name this so that when I post it, it will be easier for me to find this. Next, I want to do my actual drills. So I could just go back to drilling. I'm going to select a different tool now. These, I already made the drill hole for this. I'm actually just going back to design, or in manufacturer, maybe I can check. It would matter if these holes were size that they're like the minor diameter or the major diameter of that tap size. So this is like 1.5. I could also go into my design and just check out my holes and what they were supposed to be. Looks like these are number 10, 24 threads. Oftentimes when I get machining information from somebody, like a part, I'll ask to call out all of those threads so that I can define my drills correctly. Because that will change a little bit depending on the type of tap that I'm using. Aluminum versus steel, I might use a different size drill for that same number 10 tap. If I'm using a thread forming tap versus a cutting tap, I might be using different kinds of holes. So it's important that you just mark that actually, just like what is the thread going to be. So I'm going to go my drill, and if I don't know yet my exact drill, I could just grab maybe something that is close. Let's say it looks like this one was already defined for it. We'll grab this. But if I needed to edit this, so say this is a 125, this was an 1/8 inch drill, so it's pretty close. It's a good starting point just because some of these feeds and stuff will be relative to sort of how thin that drill is. You want to use, you're using a very small drill, it's going to be a little bit less aggressive than a larger drill. But I'm going to want to right click and edit tool, or I can click and edit it up here. I may name this like 1032 or 1024 tap hole drill. I might go online on the resources page in the hub site, look up, I've got a sheet of what the different tap drill sizes are. I'm going to then go into cutter, and this is going to be the main thing, is changing this diameter. These other parts, mostly, I'm not going to ask, and I'm not going to show you why or when we're changing those, but sometimes you may need to actually figure out, okay, what's the actual length of the cutting part of the drill, how deep is it in the holder, etc. You may need to check the number of flutes. That one actually sort of matters a little, with end mills especially. Usually most tools have 2 flutes, but end mills might have 3 or 4 or 1. And then I'm changing my diameter. So it was like a 6mm drill, I can just type 6mm, or this is specifically a number 21 drill, but I know that's 159. Oops, 159. And that should update also the shaft diameter. Now that is going to update this other important tab, which is cutting data. It is basically defined based on the diameter and the number of flutes. So when I update that diameter, it will change. But this plunge feed is sort of, it's more grouped based on size. So you do need to, you want to use the drill that's kind of closest to the drill that you're intending to, if you needed to redefine a tool. All right, so I've got that drill. I'm going back to geometry, where I'm going to select whole face, and I'm going to go again to select same diameter. I'm not going to do this middle one yet because I'm going to use a larger drill for that. For the top and bottom height, this time I can leave whole top, but I want to actually drill through the bottom. So I'm going to hit that, drill the bottom, and I'm going to add a little bit of a breakthrough, like extra depth. And that just helps to make sure that that hole gets fully cleared out and there's not little bit pieces of aluminum or whatever material just like stuck still in that hole. Going in cycle, so there's a couple of different cycle types. I typically have people use chip breaking as a default, unless you're doing very deep holes that are, you know, several percentages of diameters. If you're doing like a 10x or 20x diameter deep hole, you might use deep drilling. So now we have our tap drill done. Then we are going to do another drilling operation, and we're going to do it for this reaming hole. Now, reamers, you have to drill at 97-ish% of the final reamer size. So this is a 12mm hole. I might just define my thing as pre-reamer. Pre-reaming holes 29/64. So I, again, took one of these tools, I edited it so that it was a little bigger, and then I defined it. And I wrote that 12mm pre-reaming hole. I looked that up, basically. I'm going to go into here, and one thing that I am going to, geometry first. I'm going to grab that hole, and I'm going to go to the heights. Same thing, except I'm going to make sure this is model top. So looking at that, there was not yet this sort of pocket made. And I'm going to also drill tip through bottom. And I am going to break through. This one I'm going to break through a little further because I know that there's stock material. I'm going to drill all the way through the other side of the material. So I might need to change this later. I can kind of estimate it. Okay, that looks like it's drilling all the way through. Okay, yeah. So I could maybe make that a little larger. I could leave it as is. That should be all good. So I've done my drill. I've done my pre-reaming hole. Maybe I say this, pre-ream, and this will be a tap drill. And now I want to do a ream. So if I have the same geometry, it's pretty easy. And even if I don't have the same geometry, one of the nice ways of just adjusting this, what I did not do was change my drill type, my chip break. Okay. So I'm actually just not going to duplicate this. Actually, I will duplicate this. If I want to save some of these features, like how deep it went and the number of holes or the, geometry or something, it makes it very easy. You can duplicate here or Control D or copy and paste. So I'm going to change this. I'm going to right click and edit, or I can also double click, I think right there. And I'm going to select a different tool. Now, if I don't have an existing tool that's close, which I think that I had a 3/8 reamer in here previously, in this Tormach one, I may use the Fusion library and take a look and see if they have a reamer that I can use. Doesn't look like this is sort of defined well. This looks kind of like default spindle speed. So I'm going to, again, use this reamer instead. I'm going to edit it. I'm going to say this is my 12 millimeter reamer. This reamer is 6 flutes. So you may have to check and go back and forth and make sure which one is which. And I can just put that in that 12 millimeter and it will update that. Now, that shaft side doesn't matter so much. It's never going to come into contact with my part. But if it were like a very deep hole, I might have to think about how long is this hole, the flutes on this, how long is the whole tool, etc. For cutting data, I should already have this kind of set up for y'all. Don't need to do that. This post-processor, this number will not, I'm maybe not going to get into it, but basically it's going to need a tool number that's not 0 and also not one of the tool numbers I already have set up. So I'm just going to make this 1 or 10. Why not? We can see if we already have that. So select that. That's like just an example of like how you would define a new tool from, say, a Fusion library or a different library. And it'll automatically add it to that setup. So it's going to use this whole face. I am going to change that bottom height because reamers have sort of a flat bottom. I don't need this breakthrough depth. I am going to, well, it's flat. So reamers usually do have a little bit of a chamfer down on the bottom here. So I do actually want to have a breakthrough depth, I guess. Oops, that needs to be positive. All right, there we go. And then for cycle, I'm going to make sure that it is reaming. If I started a new hole and with that tool, it might automatically detect that it's a reamer and then it would include the reaming. All right, so now I have my ream tool and that is all the holes that I need to do for this. I could also go in and do tapped holes. This machine doesn't have rigid tapping. We do have tap holders. A lot of times though, I might tap, if it's just one part, I may tap it off of the machine just to avoid, and it does seem like I already had a tool 10 defined, so I'm gonna have to change that. Yeah, that one is already tool 10, so I'm gonna name it 11. Because I already made a tool that was a 12 millimeter reamer, that was also tool 11. Nope, that is also defined. Never mind, I need to make tool 12. All right, post processor 12. Okay. You can see there's already 2. And it actually does not like that I have named them the same thing. But they're both sort of used. That's indicated by this little arrow. That's because I've already set up this a couple times of the recording. What matters more is that everything that's in this specific setup, which I could grab just pocket side, that doesn't have any tools that are repeated, tool numbers that are repeated. All right, so done all my reaming. Now I need to do my cutting. I'm going to first cut this interior pocket, and then I'm going to cut the exterior pocket, and then I'm going to do the chamfer. So looking at this, you can see that there are interior sharp corners. Every cutter that we use is going to be an end mill. It is going to be rotating in the Z axis. Therefore, it is impossible essentially to get an interior sharp corner like this with a round tool. It's only going to be able to come up to like sort of this edge and it's going to leave a little bit of a rounded corner there. There are a couple of ways to deal with this. Either I need to go in with progressively smaller tools to try to get that as sharp as possible. I might post-process this and do with a file or something. There's a couple of different ways. But the best way is to design it so that it doesn't have this in the first place. So maybe I take a look at my design and I'm like, okay, why do I have this pocket? I have this pocket because I have this part that's supposed to fit in it. Oh, this part already has rounded corners. So I might use shortcut I for inspect. Check that out. I'm like, oh, the radius is already defined because I defined this. So it could be machined. Radius at 0.13, which is a little bigger than 125. It's generally a good idea to make it a little larger than whatever the closest like fractional tool is, just because we're going to have a bigger library of fractional tools versus metric tools. So if you make it 6 millimeters, I'm going to have to use an 1/8 inch cutter as opposed to a 1/4 inch cutter. Or if you make it 3 millimeter radius, I'm going to have to use an 1/8 inch cutter instead of a 1/4 inch cutter because 6 millimeters is slightly smaller than a 1/4 inch. It's better to make it sort of the larger size. There's also a rule of thumb, which is you should really not make it, basically my cutter length, I don't want to be more than 4 diameters deep. So if this is, say, 10 millimeters, I should not be, or say this was like 40 millimeters deep or 4 millimeters deep. My minimum size of cutter should be north of that depth. So I'm going to hide this. And what I've done is I put a fillet on it. I made this fillet 126, a little bit bigger than, I could leave it at 125. That would be fine for an 1/8 inch. I could make it a little bigger. I could make it 1.3. But a lot of times I make it like a little bit bigger than the radius so that it's easy to get in with the tool. There are also other things I could do, like dog ears, like reliefs here. I think I made, yeah, so I could do sort of these cutouts. If you can, though, the radius is sort of the easiest one. Back to manufacturing. Now I have this. Now you notice over here, whereas mostly of these were green before, now they're all yellow because I've changed my model. So I can do click and then generate, and that should basically, it just recalculates the toolpath based on the model updates. Sometimes it doesn't change if you change the model because the parts of the model weren't changed. Oftentimes it does, and yeah, you just want to make sure that that is changing in the way that you want. So now I have a cut, and I can do, because this is 126, I can use a 1/4 inch cutter to cut this. You usually want to use the biggest cutter that you can kind of fit in, because it's going to be less prone to breaking. Up to a certain extent. I would say the Tormach, really anything over 1/2 inch is not going to be running very well. 3/8 is sort of the largest end mill I tend to use. 1/2 inch is about the largest end mill. I'm going to do a pocket. I do know that I've already drilled this away. And this is the part that I want to cut out. So I'm going to do this with the pocket toolpath. I'm going to select my tool with this 1/4 inch flat end mill and make sure that either I'm using that aluminum slotting or default aluminum, whatever is defined for aluminum, because this is going to be an aluminum part. I'm then selecting my pocket geometry. There are 2 ways I could select this. I could select sort of this actual like outline of here, or I could select the face for a pocket. If I select the outline, it's gonna not look that there is a hole in the middle. If I select the face, it will look at it. You're definitely gonna need to select the face if, say, you had an open pocket, like it's open on one side. It doesn't have 4 walls. So I'm just gonna select the face. Sometimes it's useful to select the actual pocket itself because, say, you haven't made this hole yet. I'm going to go then to heights. Now, this should have used the top and bottom height that I want. Or actually, no, it's starting at the stock top. Now, that material already cut away. So I'm going to start with model top. Will be the top of that pocket. If I select the top of this pocket, it's using selected contour. So it's using my selection that I just made, which is correct for this. If I wanted to override it, I could just say selection and select that as my reference. Now it's going to cut between this line and this line, which is that pocket. Next, I go on to passes. Now, pocket is often by default defined as more of like a roughing type of operation. So the default tolerance is going to be a little flat, honestly. I really want like more like 4 10,000ths as opposed to 4 thousandths. I'm going to skip sideways compensation or explaining that, but basically I'm going to use left. There are some things that I might want to do both ways. So it's going to only cut on like sort of in the left compensation direction, which is basically clockwise or counterclockwise, depending on interior or exterior. If I was trying to clear something, I might use both ways because then otherwise it'll sort of pick up and then try to keep cutting in only along one wall. I'm going to skip that. Maximum step over. This is what starts to actually matter though. Generally, the rule of thumb is if you're slotting, so if the maximum step over is the entire diameter, so you're making a slot and you can't do anything but that slot, you are going to want to adjust your depth. And you're going to make sure that your depth is no more than 1 diameter. If you are doing full depth cuts or like high-speed machining, you're looking at more like maybe 1/10 of the diameter or something. If you are doing sort of regular pocketing, a lot of times that'll be at 1 diameter deep and 2 diameters deep maximum, and then about half of the diameter for the step over. You actually don't want to do directly half because there's some weird resonances, but about half. So I often do, to be conservative, a little under half. So 1/1, 1/2, something like that. I am going to do morph spiral machining for this, but sometimes there's reasons not to. It's just a way of doing different toolpaths, and you can try it out. I feel like the smoothing, I want it to be more like the same tolerance. Then I have multiple depths. Now, I can still define multiple depths here, even though I don't think I need it. Again, for this maximum roughing step down, I'm going to define that as my one times diameter. If you go to the machining guidelines and tips, there's a lot of those rules of thumb in the resource hub. I may want a finishing step down too. That'll give me a little bit of a cleaner face on this bottom face. So maybe I don't want to do one finishing step down. Even step downs would be only if I was doing that maximum roughing step down multiple ones. This should probably only do one finishing step down, but this would basically be like if that first step down was a lot bigger, it would just make it all even. The other thing I'm going to add is a finishing pass. This will just clean up that edge. I'm going to make it pretty small, like 0.25, or I'm going to make it even smaller than that, 1.5. I'm actually also going to do something called for finishing overlap. Basically, if it starts, say, on this little edge and it goes all the way around, it's going to end right on that edge. Sometimes it leaves a little bit of a blip right there. Especially on chamfers, I add this. So this basically just overlaps the pass by a little bit to make sure that those two paths connect. Final thing is stock to leave. Now, again, I mentioned that pocketing Fusion sort of defaults as a roughing kind of machining operation, and then you usually use contouring or something else as your finishing pass. So its default has a stock leave. This is material that will be left on top of the model. That would be helpful if I was trying to rough it and make sure that it didn't get too close to my final cuts. Because even though it's like not supposed to cut into, say, the wall, if it's roughing very aggressively, it might deflect and sort of vibrate and make a bad finish. So I'm going to take off stock to leave entirely for this. Now, the one thing that we had not gone into for drilling is linking. This is basically how does it enter or exit the toolpath? How does it sort of change Z level? Frequently with pocketing, I'm going to use some kind of ramp. There are different ramp types. Helix is sort of one of the defaults. Sometimes if you're slotting, you can't helix it. It'll go sort of along the toolpath in sort of, instead of plunging down in the Z, it'll take a gradual ramp. Usually between 2 and 4 degrees is good for ramp because animals don't like to plunge. They won't cut well. You may need to adjust that for specific types of end mills, but 2 to 4 is a good starting point. You could also, so you actually have a pre-drilled position. This was already drilled in the middle, so we could use that. And it will basically plunge right in that middle and then go out. Usually you don't want to helix or ramp. You just want to cut from the side. So I could define it as a pre-drill. I think it might know, but until I actually run it, I couldn't think if it does. So I just put that pre-drill. I didn't have to do that though. I could just leave helix. It just might cut in the air. So this is our first actual sort of machining toolpath. So now we can see so it's not taking into account, I think it might take into account a little bit that material is already taken out. But you can see it is plunging down, that red arrow plunges down, it goes around and cuts this area, and then it goes down one more level for that finishing pass and cuts this area. Now you can see these are the 2 finishing passes. Something I might do, I do often, you don't have to do this, but to improve my wall finish quality, I try to only ever touch that finish once. So if I'm doing 2 finishing depth passes, it's going to leave this usually a little step right at that Z height. I'm going to go back in here. I'm going to change finish only at final depth. So now it does that first cut. It does that first cut, and it doesn't go to the final wall XY position. And it's not till it does that second bottom cut that it does the XY sort of all the way out to the XY wall. And that will just make my surface finish on this call better. The next thing I'm going to do is contouring. So like again, Fusion you might do pocketing only as a roughing operation, then you might then use contouring as your finishing operation or something. But we're going to do contouring for this side part, or did I say we were going to do the chamfer? So we still all have all this material. So contouring is usually, it's like following essentially like an outline. I'm actually going to do something different than contouring. I'm going to do 2D adaptive clearing. Any of these adaptive ones, adaptive clearing or 2D adaptive clearing, they're basically looking at your model. A lot of these other ones that are not adaptive, they're looking at whatever geometry you define. So if your model's not well defined or you have like extra parts, the adaptive class will be affected. Whereas like a lot of these pockets or contours, it's really only looking at, if you could define it based on the sketch, essentially. Adaptive clearing also works a little differently in that you're looking more at, a region as opposed to an actual geometry. So I could say 3D adaptive clearing, that's especially the case. I'm actually going to use this though. I'm going to use this, and it's looking at all this outside. It's also looking at my stock. I'm going to define the top and bottom. So I'm going to start again with the model top because I've already faced it. And I'm going to use, I could say selected contours. I didn't select contour selection here. So the bottom, and then I'll cut away all this stuff. Now, one thing I might want to do is actually make it a little lower than that, because when I cut it from the other face, I don't want to leave a little bit of skin in between. There might be a little misalignment. So it's safer for me to actually cut a little further past this. So I'm going to say like -03 or something, so that I make sure all that material is taken out. Passes. Now, this is going to be defined. It's very similar to how pockets work, except it's going to look at an optimal load instead of looking at an actual predefined step over, because it'll adjust that back and forth. We are going to do this. We're going to do, let's do 40 thousandths because of the depth. And we're going to do both ways for this. I'm going to leave that. And I'm going to take off axial stock to leave, which is at the bottom. I'm going to leave a little bit of radial stock. Again, like this is where I want to not cut into my part when I want to like give a little bit of a border around my part, just so that when I'm actually cutting in a sort of more aggressive way, I'm not cutting into my part. This I'm not going to worry about too much because it is open. So I'm going to be able to the end mill is going to be able to come in from the side and then cut away that material. I might change, or I might check, I'm going to run this first. I might hit inspect and check how deep that is. So that's 375. That's totally fine. If I was like cutting, say like an inch, I might have to adjust my material or my settings a little bit. So this is that adaptive cutting path now. So it's looking at that stock, and you can see now it's leaving a little bit of material all the way around. I want to then remove that material. So I'm going to do a contour pass. This is a really great one for finishing operations. I'm going to pick this again. I could also pick up here. Doesn't really matter. I'm going to make this -03 again, or -02 maybe. I don't actually care about the stock top because I am not going to do multiple depths. I'm just going to do one big finishing pass around it to make the surface finish best. Leaving it left. Not doing roughing passes. I'm not doing both ways because it's just going to be one cut. I am going to do that finishing overlap. So let's just make it also like 30 thousandths or something. This lead in is like how it's going to enter. So a lot of times I'll leave whatever the sort of default is, which makes kind of smooths in that transition so it doesn't just go directly in perpendicular. And that will be that finishing pass. Now, if it was too deep, I might do finishing passes at multiple depths, or if there's a lot of material left over. Oh, it did not seem to cut. Oh no, that's just the chamfer. That'll be my, so I could say this is going to be outside roughing. You can put spaces in it. And then outside finish pass. Okay. Oh, this is already called pocket. I could call it pocket, but whatever. The last thing is that chamfer. So there are a couple ways to do chamfer. Confusingly, the chamfer, 2D chamfer tool is frequently not one you want to use. Usually you're not using this unless you're chamfering a bunch of things on a part and like deburring it essentially. And it's going to help, it's going to try to avoid accidentally colliding with other parts of your part. Usually if I have, especially also a pre-modeled chamfer, so you can make a chamfer that is not modeled, I'm going to actually use contour. So I'm going to select a chamfer tool, which I have up here, 45-degree chamfer. I'm going to select the geometry, so that our model chamfer is going to be the bottom of the model chamfer. You see this little arrow, so usually Fusion is pretty good at realizing that there is a model here, so it's not going to define it on the other side. But if I had a sketch, it might think, oh, I need to chamfer, this is an interior cut, so I'm chamfering this side. So you want, basically, the red arrow represents whatever side the cut of your cutter is going to be on of that line. I'm then going to go into, I'm going to leave height. I'm not going to adjust those for chamfers. Instead, I'm going to do the chamfer here where it is in passes. I think that this will be available only if you have certain chamfer tools selected. But this is where, if you have, and you can hover over this, if you already have a chamfer defined, you're going to leave the chamfer with a 0. If you don't have the chamfer defined, say I wanted to chamfer the interior of this corner. So actually, let's add that. I'm going to go back to geometry. I'm going to select this. I can do them both at the same time if, say, they were the same width of chamfer, which these ones aren't. So I'm realizing that I won't be able to do that. So never mind. Get rid of that one. Yeah, because this one's pre-modeled and that one's not. So I would have to do just a separate operation where this one had a different width. Chamfer tip offset. Often chamfer tools have a little bit of a flat at the bottom, so it is a good idea just to add a tiny bit of offset. And that will be our chamfer. That'll be like our chamfer tool. That is all the parts from this side. So we've actually finished the pocket side. Now the next thing that we usually do once we're done, or sometimes in the middle of while we're cutting, we might go back and forth with simulation, is we want to simulate our toolpath. So we grab the entire thing by selecting the setup, and we go up here to simulate. I'll start. There's a couple of different ways to define the stock. You can also show the toolpath or not show the toolpath. You can show the tool or not show the tool. Usually I want to show the tool in transparent mode. And a lot of times I use comparison, but I could do something else. Down here is going to basically be each of these operations. And this is sort of the playback control. So I hit play, and it's going to show me my simulation. So it's going all the way past, and then it's going over, and then it's going to do my spot drill. It won't always demonstrate every chip break in like chip breaking drills where it's going to, they're called peck drills basically because it lifts up a little bit after each, like it pushes down and drills a little bit and then picks up a little and drills down more and picks up a little. You're not going to always see everything simulated. You'll see sort of only the main part. So I also want to now skip ahead. I can skip to next operation. Also say, so I'm going to skip to the reamer. I'm going to skip to this. Now I'm looking at this. Now, if I wanted to double check that it was not engaging that tool, I could also run it backwards. If I hit pause, it should regenerate on rewind, or if that's not checked, check it there. Now I can play, and I'm making sure, yeah, it didn't, it looks like it where it entered, it just entered in that middle area where it wasn't touching any of the material. Now, as you can see, when it's cutting, it is changing the color. So this is the comparison mode. Basically, red is going to be if it cuts into the part. Green is going to be it's very close to the actual geometry. Blue is going to be there's material left. So probably what we'll see is that the red one thinks it's too small. Basically because probably the hole size that it models at is like a little smaller than the actual tap drill size. This is modeled probably at the minor diameter, I would say, of that hole, whereas tap drills actually are like a little bit bigger than the minor diameter. This one is blue because I think I actually made that a 1/2 inch shaft at first, and then I changed while we were actually running or defining this, I made it a 12 millimeter shaft so I could show millimeters. So sometimes there are times where your model is actually, you can kind of change the geometry while you're doing CAM. Make sure that you know that that's happening, because there's nothing more confusing than having a part that almost matches your model and you realize that you had made some adjustments in CAM to the geometry and we're not thinking about it. So I might also be looking at this and making sure that it didn't engage too much, especially at that first corner where there was like a little extra material. So if I'm doing a contour sometimes, those areas where it's not even all the way around, it might engage really heavily in these like little corner areas. So I'm just watching this. I didn't have to watch this because I'm pretty confident that I designed everything right, but it is a good idea to watch these. If there was a collision, you would see it in red here, but all that means is really like a part of the cutter touched a part of the model that shouldn't have. It doesn't really mean that this is all good. It could still be hitting a fixture or too aggressive or something, it is not going to necessarily save you from bad toolpaths. So now that I've looked at this, I can exit the simulation. If I see something I don't like, oh, there's this little step here, that's actually fine because it's cutting past here, but I can go back now and adjust those holes, decide, oh, I wanna make sure, oh, something that I wanted to check, will I be able to have access to this hole from this side? If I just drill to the bottom, I wouldn't be able to get to this hole when I flip it over. I need something to indicate this off. So I'm gonna actually do my simulation again, and I'm gonna skip to the end of toolpath. And yes, I did drill all the way through. There is a hole available on the other side. So that's good. And I don't really see a little lip. Granted, that reamer might not be 100% exactly accurate to the definition. So it's worth either checking that reamer tool is defined accurately, it has the right lengths and sizes, or maybe when I first run this, I have to check it. All right, so that was my first side. Now I have my second side. We have to do it all over again. It's not that bad though. Most of my stuff has already been done. And the other thing is I can actually just sort of duplicate this entire piece, say if I have a lot of the same kinds of operations, and just redefine it. So now I'm going to call this shaft side. I first, though, want to change my z-axis orientation because now I'm going to be z-axis orientation from the opposite side. So I am going to select this face and like that. Now, I could use the corner of the stock again. The problem is when I cut this stock, it's probably cut on a saw. It's probably not exact size of the sort of this representation of this block. And if it was at an angle, I'm going to get a misalignment between this side and this side. So that goes back to a little bit of why it's really important, to also cluster your feature. Like if these are features that matter relative to each other, I try to machine them all from one surface or one setup. But because I have that hole, I am actually able to find the middle of this bore. Usually it's an orthogonal edge or cylindrical feature that can be used to find the origin of a part. Sometimes you can also do middle, but again, because the edges of these aren't going to be necessarily machine cut, they are not reliable. This is part of the reason why sometimes, especially like in universities, they will teach you to machine all of the surfaces. So you have this perfect block of aluminum that is exactly 1 by 1 by 2 or whatever, and it's exactly flat first before you machine any parts. That is fine, but it is really tedious. It adds so much extra work. It is a lot faster if you sort of just design better around our stock that you can cut on a saw, and then you save all of that time. Granted, sometimes that's necessary. So I could select, instead of selecting my stock box point, I could select a selected point. And I could say, oh, I'm actually going to select the top and the middle of this bore. There's a problem. I can't get to the top of this. I don't have access to whatever this top face is. I'm just have a hole through it. And I don't really know where that's going to be. I might say measure how much is left and adjust it. And I could face this down to the final size first and then find that bore when it's actually at the final height, like sort of pre-machine it beforehand. Sometimes that's something I do. If I don't have access, say, to this feature, I might just run the face mill manually and just creep up on this height. But what we do actually have is the bottom surface of this part. So I could probe actually to whatever this is going to be sitting on, which will be a ground parallel. And that's a reliable way for me to find this Z depth. That might not be perfect for some types of parts that don't have a good flat face, but it's good for this kind of part. So I'm actually going to try to select that bore, but on the bottom face. Now, unfortunately, oh yeah, it does have accessibility analysis. That's showing what I have access to. That is not what I need though from here. I need access to pre-machine features. So I want to define it. Now, on the machine, it's really easy to be separate about your X, Y, and Z definitions. I can define this face, and then I can define this face. It doesn't need to be an actual corner. I can define the Z depth as something completely different from an actual corner or like a literal feature like how it is here. Unfortunately, that's not reflected in CAM. So I have to basically make a point that is at the bottom of this surface, but is here in order to figure this out. I did, though, already do that. So I went back to design. I made a sketch. this one should work. I made a sketch. It's right here, and it has a center point. I could also, I could do this another way. Maybe I like want to extend these two, and I'm going to find this edge. But this is a round edge, and I don't want to make sure that it's like on that exact tangent line. So I'm going to do this, and that's going to be my origin. And basically what's going to happen is I'm going to define my x and y via this hole bore, and I'm going to have either already defined or define it afterwards the parallels before I put this in as my z depth. You don't necessarily need to understand all of that. This is frequently what I end up going over with people when I'm helping them. I'm also actually going to call this side B. I don't need to change my stock at all, but I could potentially do from preceding setup. That should look at the last one. The problem is I have a bunch of setups already defined, so I'm just going to keep it as this. All right. So much of this can actually be the same. So again, I mentioned that we used, when we made this, we used sort of model top and stock top. So if I generate this now, it'll actually be right where we want it. It is going to use the stock top of this new setup and the model top of this new setup, and it's going to be defined there. We're not going to be using these spot drills because we have already drilled them from one side, nor this reamer. And now we have what's left is the pocket and the outside roughing. So we're going to be roughing this area. I could do it as a pocket. I could also, I'm probably going to do it actually as an adaptive clearing. So a lot of times when I'm clearing a lot of material, I like using adaptive clearing because it is sort of looking at, again, optimal load. It doesn't really care about just like a fixed step over amount. It's trying to make that load on the tool as it's cutting the same. And that is going to be better for the cutter. And so I'm going to use my outside roughing, which is an adaptive clearing cut. I could also just, have started with a 2D adaptive clearing. That would have been totally fine. But for this, I'm not. So I'm going to keep my 3/4 inch tool. Actually, I'm going to double check how high this is. Okay, so that's 1 inch. Now, okay. Yeah, I was going to say that the entire part is 1 inch. So if it was 1 inch, that is getting a little bit past that like 3 times diameter, 4 times diameter rule of thumb that I like to use. So again, 3 times diameter for like a lot of pocketing, but 4 times diameter is the max generally. You're not going to get a lot of tools unless they're specialty that are longer than 4 times their diameter. All right, so check that that's 0.625. I'm going to try to treat this as it's going to be mostly side milling, so it's going to take a very small step over. I could also do multiple depths if I wanted to. There's a lot of different ways. It's a little more wear efficient to do it as deep as possible, but sometimes that's not good based on how torquey your cutter is or how you're running it. So I might do maybe a depth cut as well. So first we're going to go to geometry. So now we're going to get rid of that geometry, and I'm going to do this as my geometry. I could also grab this face, but I think it'll find those holes. I don't want to grab this because it could actually, now it's outside. That I think will include this, and I'll cut this away. So I'm going to grab this. Oops, still on. Nope, again. I'm going to grab this as my geometry because basically it won't cut this middle area, but it'll cut all this stuff out. It's going to look at the stock and try to cut away all that stuff. My heights, now I don't want to actually use this, whatever I selected. Oh, yeah, that was that. But I don't want to make it all the way to the bottom because I don't want to cut away the material. I also don't have to do, for model top, for this I would want to do model top because there's still material here. But say I had like a pocket that was inside of another pocket, I could define the top of that second lower pocket as the top face. Now I'm going to go into the passes. I'm going to leave my tolerance here because I'm going to do this as a roughing, and this will just make it a little faster to compute. I'm going to do my optimal load now as more like something like 25, so a tenth. Sometimes you can make if you're doing both ways, make your optimal load other way, like a little less, just because it's sometimes different on the cutter. Now I'm actually going to leave a little bit of stock on the bottom surface as well, just so that this is got a nice clean surface when I'm done. And now we'll see our cut. So You can see these yellow, that's like the other way. And it's basically, it's kind of going back and forth and trying to remove this material in an optimal way where it's a sort of engaging the same amount of material always. So now I need to do my finish pass out. I'm going to need to do my finish pass both on the outside of this cylinder and on the surface of this. Those could be two different ones. I could also use a pocket. So maybe instead of making a pocket from scratch or making a pocket of contour or whatever, I could also do face and like avoid this as a region. So I could like define geometry to not touch. I'm going to actually just grab this pocket. I'm going to Control D. Often it's very bad at duplicating in between ones. So just make sure that it doesn't bring both pockets in there. Sometimes it automatically grabs it. And now I'm going to edit that pocket. All right, so my 1/4 inch flat. My geometry is going to be same as the other one, but like this. I had already adjusted my tolerances and stuff so that they were at 40 thousandths. I don't need multiple depths for this, but I do want those finishing passes. Actually, I want a finishing, no, it doesn't matter because we already roughed it. So it is already going to be a finishing step down. If I was roughing it, I would want a finishing step down as well. Got this is the step over. I think there's only actually 10 thousandths left. So that's going to be, oh, that is wrong. So you can see immediately something about my height is wrong. Oh, that's my bottom reference now. Okay. And there's like that finishing pass. Cool. So I'm going to actually call these, rename these. So I'm going to call this shaft roughing. And then I'm going to call this shaft finish. There we go. Delete this. And we have our chamfer. So we do have another chamfer on here. So I'm going to take my chamfer that I had duplicated. I'm going to grab this now as my geometry. I am almost positive that I can leave everything else the same because my settings were sort of generic. And I just left this little chamfer tip offset. And that should do that. Now, I don't remember if I did the finishing overlap on this chamfer. This is actually something I want to do. And I want to do that on my other chamfer, which will be here. Finishing overlap. 0.03, sure. I'm going to name this chamfer. And also name this chamfer. It doesn't care if they are the same name, if they're in different setups, but it does care if they're in the same. You also might notice that I am sort of thinking a little bit about my tool changes. Generally, you want to reduce the number of tool changes. So I wouldn't usually do a bunch of things like pocket this and then do the drills and then do the outside roughing and then do a chamfer and then do the outside finishing or something like that. I want to sort of group my tool changes. So I only change this tool 22 once. And then when it's done, I change to 27 and then I don't need to put 22 back. That's more about cycle times and how fast you're machining. That matters when you're doing production. Now I'm going to show you though, say I did want to edge break this and do like a very light chamfer on this. That's when I would actually use this 2D chamfer pass. Oh, selected the wrong. Make sure that's my active so that when I make this 2D chamfer. So this will be a chamfer that I haven't defined. I'm going to grab, say, this as my chamfer. Because this is so close to the edge, potentially if I had a big chamfer, the side of the tool might run into this. So this is when that 2D chamfer comes into handy. It'll look for these areas and try to make sure that it doesn't hit anything. So you can see now, it actually is avoiding that one little area because it is like, oh, the cutter, that cutter is potentially going to collide with it on this side. I could adjust this to make sure that that doesn't happen or make it less likely to happen by increasing my chamfer tip offset. So say I also didn't define the chamfer width. So I'm going to make this like sort of 1,000th or something. This is going to be like a very light chamfer. It's just to break that edge. This is the chamfer clearance. So this is how close it allows the chamfer to get there. So I might reduce that if I feel pretty good about it. And then this is the chamfer tip offset. By increasing my chamfer tip offset, I can actually get it close to the edge of the shaft. It's not going to be able to be any bigger than the radius. So I think, the radius, square root of twice the radius should be the length of that chamfer. I think it would be somewhere around there. So that's going to make it sort of deeper. It's still not cutting. So I might be able to adjust this until I can actually hit that whole thing. Probably not. I sort of didn't design this so that was possible. You can see actually it's getting a lot closer now. So it's hitting it all the way on this side. It's not getting it all the way on this side just because it gets kind of a little too close. Say I wanted to keep on adjusting this, I could keep doing that. To see if I can get it, maybe it is 1, 2, 5. So now I can actually get the entire way around, and it's going to just be doing that chamfer really low, right on the edge. I may need to double check that that chamfer tool is defined properly, because if it's slightly different, it may not have that depth of face available to cut like that. All right, so that is all of my parts. I may want to simulate it. Sometimes it's helpful to just simulate this part first and then go through again, make sure that everything looks right. A lot of times if I'm doing two-sided operation, now I'm going to actually grab both of them, so pocket side and shaft side, and simulate. And it will run through both of them. So I'm going to skip over because we already did the pocket side. All right, so we've done that. And then does this part, and that's chamfer. And now it's going to start to do stuff on the opposite side. Now you would, obviously the part doesn't flip over, the machine doesn't flip over by itself. You would actually be taking this out, blowing it off, resetting it up, putting it back in the vise, finding that origin, and then you would start running this. But in simulation, we could just do this faster. And again, I might look at this and be like, all right, does this look like a sort of, it looks like it's plunging the entire end mill into there, or does it look like it's just shaving off a little bit? The idea is that it should just be shaving it off a little bit. Now it's cleaning up that face. Now we have our final part. So I could hide, say, bodies. It's a little easier to see the comparison. You can see, yep, we've got all these parts. Now there's no red down here. Reds are collisions again. We mostly say I tried to chamfer the bottom of this and this is not an inch. That top of the tool might collide with the top of this part. That's where you would see a red line. The last thing that I'm just going to show is templates. So a lot of what I do is I showed you sort of how to just duplicate an entire setup. You can also do that between parts. You can copy and paste setups between parts if you have two files open. But another thing is that if you have a model that you've set up and you feel like this is a pretty good setup, the geometry is nice, all of your settings are something that you're probably going to use again, you can save this as a template. So I'm going to save, I have to save you can't save the setup, you save the collection of toolpaths. So I can now instead, store as template, and I can call this something like one side, one aluminum parts. I like to use templates. That's how I often will train people, is I'll give them a template because it might have extra stuff. So say you brought in this to a new part. Say you use this as your shaft side template. So we'll actually kind of show you what that might look like. Is instead of duplicating this, I would have put the body back. I have this pocket side template that I just defined. Now I'm going to make a new setup. I'm going to define it with my model. I'm going to do my selected point, make sure that that's here, just like I was doing before. Oops. I'll leave that as model orientation because it's correct. I'm going to leave selected point and use that point, just like we did previously. So now that's set up, it's a blank setup. And then I can say create from template. Now I grab my side one aluminum part. Now, As you can see, there's a lot of red things. That is because basically some of these things like face that's using stock, it already is looking at that. It is happy. It's a stock and there's a model. That's all it needed basically to figure out how to face this. If I were doing adaptive clearing, that might also be totally fine. It doesn't need to do any updating. However, most things, they need some kind of geometry, so those are going to be red. Now, again, say I was doing these drills. Oops. I just want to edit it. Then I would just select my whole face. And now it's going to use the same parameters, but now from my new geometry. So say I wanted to actually drill and ream using this, or I can just delete. If I know that I don't need reaming. Maybe I don't need it because I've already got it. And so I'm just going to do this outside roughing and outside finishing perhaps, and this chamfer. So with sort of generic toolpath types or sort of setups, it will create a template that then can be used. You do want to be careful because it might be designed around really specific parameters or specific machine, specific material, but it's a good way to save on a lot of these and not having to do all of the figuring out of the speeds and the depth cuts and other things again and again. A lot of what machining is about is sort of figuring out what is working, trying it out, and then using those same settings again for your next part because you've tried them out and you know that they work. So that should be everything for CAM. Oh, there is one last thing. It is posting. So when you have got to this level where you have checked everything, you are happy with your machines, you have checked your tool list, so you've gone to your tool library, you've gone through, and you've made sure all that tool numbers are not overlapping. Because if you put the same one, the mill doesn't know that they're two different tools. It just sees tool 22 and tool 22. It doesn't know that it's supposed to be an end mill and a chamfer, so it'll just keep running. Do post-process. So post-processing is basically, I'm going to take all this stuff and now I'm turning it into code that the machine can read. So with my setup selected, or if I was just doing some of these, I could select just those parts. If I didn't want to include some of these, I can also do press, which just it makes it not post or optional sometimes. So post-process right here. Different from post-processing, which is doing secondary operations. I go up here and I would select my post-processor. So I have the two ones that we use, Pilot and ShopSaber WinCNC Control on the resource hub. You can also go these came out of the Fusion posts. So you can go and find these and download them. I'm going to put my name. I'm leaving all this stuff as whatever the defaults are. I sometimes will change these if I have specific things I need to reduce speeds or override stuff, use arcs, etc. But mostly for what we're doing, we're just going to leave everything default. I'm finding the location that I'm going to put the output folder, and then I'm going to be posting. Now what I should be able to see is spin up the NC code. And this is actually what that G code, what the machine is going to see. So again, it doesn't have any information really. These are comments, so it doesn't actually see this information. It doesn't know that these are supposed to be doing. All it's seeing is a list of coordinates. So it doesn't know that this is a pocket or a hole or a tap or whatever. All it sees is it's at this location in the X and Y, and it's at this location in the Z. That's where I'm going. One thing that's helpful about a lot of the Fusion posts is that it will show you your Z minimum for each of your tools, and it will kind of list the tools here. That helps you go and set up your tools. But this can also be a good way to double check and kind of gut check. This is a little weird. So my reamer is going -1. No, that's right. I was thinking that it was at the bottom. I defined it at the top. So if I had defined, say, 0 as the bottom of the part, it really shouldn't be going negative that much. Maybe it goes a little that 30,000th or that 60,000th breakthrough amount. But it should be no higher, really, no lower than -0.1. That's a good way to sort of protect yourself from accidentally crashing machines. Is you look at this Z minimum and you're like, oh, -3. This is only a 1-inch part, and I defined it at the top. It should never be -3. -1.2, that seems fine. That's a little bit past a 1-inch part is 1.2. So I can look and just double check, sort of again gut check, to see that these are all reasonable values. And then all I'm going to do is basically pass this on in a USB to my machine. Now that post processor is specific to the machine, so you would have to use a different post processor for, say, the Meltronics, or for a Haas, or for a different Haas that has a different controller, or a different Tormach that has a different controller. But ultimately, you can actually use the same thing. You can use all this stuff is all the same. It's just the post processor that's different. You can think of the post processor as essentially a language interpreter. It is taking all this that is sort of universal, and it's converting it into Haas or Tormach or Shop Saber language. And that makes CAM very universal to essentially all CNC machining. These are all mills, 3-axis milling, but it's not super different from 4-axis or lathe, but your tool paths are going to be a little different. So that's it. I hope that was helpful. I may be splitting this also up into some more sections, but definitely you can always reach out to me if you've got specific questions. The other thing I encourage is just try it out. Try to see if you can get your toolpath, maybe compare it to mine, send it to me, and I'll take a look and flag the things that are going to be a problem. There's a lot of things I glossed over around feeds and speeds, around parameters, around tool generation. So you may need to, depending on what you're trying to do, there's going to be different areas that you're going to want to focus on.